Assalamu alaikum, everyone. Welcome all to this joint meeting organized by the Center of Excellence in Energy Efficiency at KFUPM and the Association of Energy Engineers Saudi Chapter. Today's webinar is on the impact of Industrial Revolution 4 on energy efficiency and electricity market. So we thank everybody who's joining this collaborative event between the Center and the AE Saudi Chapter. We're very happy to see this collaboration continue. It started a few years ago and it continues to evolve. So we thank everybody who's joining us today. My name is Mohammed Al-Wadaifi. I'm the chairman of the technical committee for the AE Saudi chapter. And today's event is very special. We have a very special guest today, Dr. Fahd Sulaiman, is the director of the Center of Research Excellence in Renewable Energy and the director of the Center of Excellence in Energy Efficiency at KFUPM. So we're very fortunate to have Dr. Fahd speak to us about the fourth industrial revolution. He is the founder and the supervisor of the Students' Energy Club at KFUPM and the founder of the Renewable Energy Incubator at KFUPM. He's also the vice president of our AE Saudi chapter. He was involved in developing several education programs and courses on energy. He received his bachelor's degree with honors and a master's degree from KFUPM, his PhD from the University of Waterloo in mechanical engineering, with specialty in energy and techno-economics. He was a postdoctoral associate at the Center for Clean Water and Clean Energy at MIT for 1 year. In addition, he was a visiting consultant professor at the National University of Singapore, University of Oxford, MIT, and also we had the pleasure of him being visiting a consultant at Saudi Aramco when we worked with him a couple of years ago during his visit. He's been involved in publishing more than 160 scientific papers and technical reports. He obtained also several patents, some of which have become actual projects. Dr. Fahad's research expertise includes solar and wind energy utilization and grid connection of renewable energy to the grid. He's an expert on cogeneration, trigeneration, water desalination, and advanced thermal power cycles. Also electrical grid connection, as we mentioned. His expertise covers air conditioning, techno-economic studies for energy systems and energy efficiency, and also in energy policy and regulation. So a wealth of expertise with us today, and we're very excited about today's webinar. So Dr. Fahd, it's all yours, so please take over from here. I think I'm going to stop sharing and you can share.
طيب السلام عليكم ورحمة الله وبركاته. I would like to thank Engineer Ali Al-Qahtani, the President of the Association of Energy Engineers, as well Engineer Mohammed Al-Wadaifi for helping us to organize this event along with the Center of Excellence in Energy Efficiency at KFUPM. So today I'm going to talk about the impact of the fourth industrial revolution on the energy efficiency and electricity market. So just think about it now, based on what you can see here on the slide. People, when they want to travel, they usually moved just by walking, then of course with the horse carriage, then of course later steam trains comes to the picture, then cars were developed, then later more advanced car as well with airplane. And the question now, do you still need to travel? And as you can see, even for our meeting today, we are making this one efficiently and online. So now even people, they have this similar feeling, not necessarily exact, but similar feeling of traveling and playing and so on, while using artificial intelligence and augmented reality, as you can see here. So the world is moving, and there will be more technology adapting the industrial revolution technologies. Now, you might ask, what are the first industrial revolution, which is around mechanization, water power, and steam power. Then the second industrial revolution was about mainly mass production, assembly line, and electricity. Then the third one about computer and automation, and the last one is about cyber security or cyber physical systems, as you can see here in this in the fourth industrial revolution in this slide, where you can communicate the data to improve the performance and the efficiency of any system. So moving forward, you might ask yourself now, what is the first industrial revolution? The first industrial revolution started between 1733 to 1840, and within this period there were different technology developed, which is considered for now is simple, but at that time it make a big difference. Is either for flying shuttle or for steam engines, which make a big difference, or cotton gin or steam plow for agricultural production. So within these themes, after that, there was second industrial revolution, which was between 1870 and 1914, which is mainly around electricity, inventions and improvement within these sectors, starting from automation, then later with telephone, airplane, and moving assembly line at around 1913. Then there is the third industrial revolution, which is mainly about computing and electronics. So it started with around 1950s with electronics, then with computer, then with the internet, then you have cloud computing. Then with the cloud computing, you will notice that what? You'll notice there is more data you can deal with it. So people, the fourth industrial revolution started around 2010 with more technology improved for the virtual world, robotics innovation, robotics era, and technology advances. And still there will be more things to come in the future. Now, I'll go back, and if I go back one slide, you can see the second or the third industrial revolution took around 50 years from beginning to the end. So people, when we talk with people about fourth industrial revolution, still we are just within, let me say, 10 years is considered relatively short for these people to absorb what could be in the future. What is more important in the educational sectors, in the business sector, is to be ready and start to adapt that one and start to train our people toward fourth industrial revolution. Now, if I want to summarize everything together, I can say the first industrial revolution was about mechanization, where industrial cities were start to develop and factories, and it was around steam engines. The second one was about mass production, and where you can have scale economy, where it make an impact on the economy in scale wise. The third industrial revolution was around automation, so you can have more global production network and input cost. And the fourth one, which is we are relatively at the early stage of that one, about robotization and digitization. And of course, it is involved or revolve around cyber physical systems. Now, as you can see here in this slide summarizes some of the component of the fourth industrial revolution, either through augmented reality, Internet of Things, system integration, big data, additive manufacturing, and cloud computing. Now, just to imagine how everything will go and move, the cycle is getting big and big and big. So now, if you take an example about automation, because of automation, we have robotics and additive manufacturing. This help us to have, for example, drone. We start to have autonomous automobiles and intelligence process. So this is already the second cycle here, or circle. Already all of us may be aware of it. We are familiar with it. Now we are moving from the second circle or the middle circle here to the outer circle. So everything is moving outside slowly with more feasible solution and practical solution, similarly for all the other domains. And if we move further next, just to try to have an example before I go more deep about what are the potential cycle. When we talk about digitalization, we are talking about collecting data, collecting behavior of people. Are you at rest? Are you active? Are you moving outside? Some more information about you. Then with this information and with these sensors, this data will be processed. And using the data collected, it will be processed, it will be analyzed, then it will go to analytic machine, for example, machine learning or Internet of Things. There will be iterations until you have better analytic engines. Then this engine will provide you some feedback and control for recommendation, how you are behaving from health point of view, from energy point of view, from electricity point of view, from money point of view, and so on. Indeed, some of this information is available, but not available for us. It is available for Facebook, for Google. In the future, we'll be more aware of it, and it will be reflected on you. And if you go and dig and read about digital marketing, digital e-commerce, and so on, you will see new business model are being established, and they succeed with hundreds and billions of dollars just using the data where you are exposed to it more, and so on. Even now with the insurance and so on, there are a lot of examples. We'll focus now toward what is relevant to energy efficiency. Now, just this picture needs to be well understood before I move next. Now, you can see this is the power generation system on the left side here. Here you have the power transmission and distribution system. And here you have demand, where you need demands of electricity and power and heat and so on. And in summary, of course, there is microgrid, which is quite independent grid out of the main grid. And there is energy control and monitoring room. Here, in the future, you will have more data where you can have better control, better marketing, and so on. So let us take an example here. Here example, just we're talking, you will see when you talk about industrial revolution and linking to energy, we'll focus more toward Internet of Things, because there are real example and more practical example around this one. So here, what do you see here? For example, either you are in the distribution feeder or distribution substations, you can have huge amount of data for distributed generation, for electrical vehicle, for energy storage, for smart meter, and so on. As well, you can collect a huge amount of data about transformer monitoring, line regulator, and inventory and so on. So what can you do with this information? You can do a lot of things. If you have more data, you can do more. Actually, now the big countries are just fighting for data. Data is the future, or the oil, the future oil, the future wealth. So what can you do with this data? You can have develop better GIS system. You can have preventive maintenance system, better inventory management system, better metadata management, and so on. So you will have a lot of options. And with better data analysis, better, more cheaper sensors, cheaper data centers, which is coming to the picture as a real fact. So all these will be more achievable. Now, if I try to understand what is Internet of Things, of course, I'm sure some of you are aware of it, but it has different components. To succeed for the Internet of Things and you have the right platform, you should have devices where you collect data and communicate data. You should have the right protocols so you can communicate the right data and develop the right model. You need data storage. You have to analyze the data accurately, and then you apply it somewhere. So this cycle is revolved around Internet of Things. Let us link this one with the energy now. Internet of Things, you can collect digitalized energy generation. You have more data about energy generation. Then you can have data about all the main components within, for example, power plant or distribution, substations, more data about you can use the Internet of Things to optimize energy grid and have better communication for the distributed energy, for the energy storage. And what is also critical within this one is about demand and supply responses. Even if you have better data, you can relatively control the demand and not just be responsive. You can be proactive to control the demand if you have more data. We'll cross this example soon. So one of them also very relevant things with the Internet of Things is data center. So with the data center, you can collect all the data from the power plant, from the smart factories, from the smart building, from the farms and distributed network. Then what is the challenge is how to manage this data and analyze it to end it up with strong recommendation where you save money, improve efficiency, and so on. Now, if I want to summarize everything in addition, so when you talk about the power Internet of Things here, there are different layers. You need the first to sensing layer where you collect data from either generation, transmission, or consumption. Then unified sensing and access data. Then you have a network layer. Then you have platform layer where you have a big data, integrated cloud platform, artificial intelligence, and Internet of Things. Then the applications. So there you can see there maybe there are quite challenges if we talk about energy because it is relatively at early stage. But if you think about what Facebook is doing, what Amazon is doing to predict the customer needs and provide the service to you while you are thinking about it, you can imagine in the future how this will be achieved for the energy sectors. So it doesn't mean it is easy when you talk about Internet of Things, which is relevant specifically also to energy. So there will be some security challenges. There will be some challenges related to integration of internet with substations or subsystem of energy system. What are the best architecture design? What are the proper standards and policy? There will be some concerns about privacy. And there will be also concern about energy consumption. But just with all these, yes, there is a challenge, but think about yourself. Already you are you are accessing the bank, your account is available, anybody, you can access your account anywhere in the world, and still you feel the data, the information is secured. So with the development, these will be become more secured, and especially considering that the sensors becoming much cheaper, the data center becoming much cheaper, the capacity to store the data and deal with the data becomes more efficient and smaller size. So there are indeed a lot of enablers toward have more efficient and feasible Internet of Things for different applications. Now, let us now move with some specific application relevant to energy efficiency. Now, to achieve really or to apply digital technology to improve the energy efficiency, you can think about data gathering. So you need to gather the data through sensors, smart meter, distributed ledger, and interfaces. Then next step, you have to analyze the data through some algorithms, artificial intelligence, and you have to make some action and physical action around that one, either to have smart control, automation, and so on. So within these three steps, you can achieve more efficient, smart energy system. Let me give an example now, a simple example. Now, when, I'm sure maybe most of you or all of you is aware about building energy management system. Building energy management systems, you have some building energy management systems, and at the end, while you are in your office, you will see the data. Now, is it smart enough at this status? No. It will be more smart and more efficient if you have advanced digitalized office. What does it mean? You can predict the weather. By prediction the weather, it will give you a signal. Please reduce energy consumptions. If it is based on renewable energy, please notice that the temperature will increase. You have to manage this. You have to be careful about that. And even not just about weather prediction, also it is relevant to, for example, about occupancy within one unit, within your office, within your campus. How busy is it? And based on that, there will be recommendation in the control room. So this is, we call it advanced or smart building energy management system. Now, this is also another simplified one where it can show the flow of the information either from smart home to smart grid. And this smart grid, the people in the utility or electricity provider, they have more data and they can communicate. They have more valuable data from your house, from the smart meters, and they can have better communication with the renewable energy resources and conventional energy resources for the generation side. Now, based in addition, from other angle, I can say there was some assessment and prediction. If you want to implement industrial revolution, technology X or Y for your house or factory and so on, how much benefit you will get. Based on one of the assessment, it was for the building up to 10% less energy use. For the transportation, it can be more than 50% lower CO2 emission in 2050. We're talking about conventional type, diesel, gas, gasoline based transportation system or oil-based transportation system. Also for the industry, you can have up to 30% energy saving. And what is also very critical for the decision maker and the planner is more flexibility in the demand capacity. You even yourself, you can have better control for the demand by providing incentives and notification. I'll give one practical example. As you can see here, this is a practical example and reality. Using artificial intelligence, Google was able to reduce the cooling demand by 40% in its networked data center. So there is a high potential to reduce energy and to save energy The point here, the challenge for us is how to make it feasible solution and to overcome the barriers around that. Now, of course, there are specific design principles for the Industrial Revolution 4.0. One of them is interaction or interconnection. You have to connect between devices. There are many tens and hundreds of maybe thousands of devices. You have to have easy interconnection between them. The other main challenge or design principle, I think someone is using annotation. Please avoid using this one. About information transparency. So the information, you want to exchange information and you want this information to be transparent. There is a challenge about policy and privacy around information transparency. The other one, you should have more decentralized decision making because you're working with fast and in millisecond decision needs. So it should be decentralized all along the full spectrum as well. Eventually, of course, you will need also technical assistant either from people or even machine itself can recommend some technical assistant. Now, of course, one of the also main challenges is the policy setting. You succeed for the application of Industrial Revolution 4.0 in the energy sector or the electricity market, you can succeed, but eventually will be limited because of policy. So we need the policy to enable and to develop regulations, the policy makers. As well, there are other things which will enable and to make it successful business is to develop, for example, ensure, educate, protection from the cybersecurity and data privacy, strengthen the trust between different technology. It should be feasible solutions. Each people, any person, he can have equitable access to the digital system. And we need to increase the skills because mistakes create a big damage. And of course, we have to minimize the negative environmental impact. Why this comment is, or what does it mean here? Actually, when you go with digitalization, this means you'll have more control system, you'll have more sensors, you'll have bigger data centers, all of these consuming electricity and impacting also the environment. So this should be considered in any design, especially if it is mass size. And of course, here, encourage technology and business model innovation. We have to keep innovation so we can adapt more demands. Now I'll go with some examples and you'll see, you can absorb from these examples the reason. You'll see some of this example has been done in microgrid levels and it has been done in some remote areas. Why? First, remote areas, the electricity is expensive to them. Second, if you have microgrids, you don't have this a lot of restriction about, let me say, grid connection, about policy. You have your grid for in this village, and you can experiment whatever, Internet of Things or blockchain and so on, whatever you are looking for. So this will help also to implement more smart energy, solar energy-based system. So you can have more acceleration of the electrification timeframes, improvement of service delivery, and reduction of electricity cost, and best or better redistribution of social benefit. So now I'm going to provide some examples where this one of the applications of Industrial Revolution had been implemented or has been implemented. So first of all, as I just explained in 2 slides ago, Mainly it was implemented in these examples in off-grid and where you have unreliable grid context, and you want to examine and experiment what can you do with any of the Industrial Revolution 4.0 application or technology for energy market. So of course, just for information, since 2010-20, more than 300 people have chosen and opted for off-grid solar to gain access to clean and reliable electricity, and the cost of mini grids and off-grid or mini grid and microgrids is becoming and will become more feasible and much cheaper within 10 years from now. And digital innovation will continue to be the major driver for off-grid solar market. We need more advancement in the technology, and in addition, with around 1 billion people with without electricity access, there is a room and to provide them efficient solution, especially if they are in urban and away from the main sources of power generation and transmission lines. Like, let us have some example and see how what we just discussing has been or have been applied. So this is one experiment which was conducted, for example, in Nepal, where in this village they have 1,000 people, and there are around 275 households. And please consider in some of these examples, the demand of electricity is within reasonable scale, and their needs also reasonable. So for this small village, the power peak reach is around 100 kilowatts, which only serve the basic needs, and the distances between the houses up to 7 kilometers, or let me say the power line about to 7 kilometers. And they have installed smart counters, and also they used buy energy and prepaid systems and cooperative. You have to collaborate with your neighbors and so on. So based on this model, they tested this one, and the main technology used here, Internet of Things. It was remotely communicated. All the data can be collected from each house using mobile and wireless connectivity and smart meters. They were relatively succeed within this experimental work. So this is just one example. Another example, which is about demand forecast. It is linked with the demand forecast. Of course, it has this project, the name of this project is Blue Solar Optimization, and it has been experimented and tested in microgrid in Thailand, and it went through different phases, and they use a smart distribution system, and they collected the load profile, and based on that they make their plan. So briefly, the overall system here is revolve around collecting the data on the cloud with low-cost computing, and develop a complete running system that meet the needs of this village. Of course, as I mentioned before, experimenting this technology with the microgrid give you a lot of flexibility to understand the system and make it more feasible system. Of course, one of the also system which has been tested or technology tested is pay-as-you-go system. And in this one, they are not just using Internet of Things and computing, they are using more systems. So the project is B-Boxes, smart solar remote system. So they use the solar home systems, Internet of Things, machine-to-machine learning, technologies and automatic enabling and disabling of the solar home system. So based on that one, again, they achieve really good achievement. And what does it look like to make it simple for you? Of course, the demand, as I mentioned, is relatively low. What they said, they went for some houses, and they implement within this, let me say, microgrid, and they deliver to them this box. They deliver to them this box, and it has different outlets. One of them, it should be, for example, for the TV. The other one for lighting. The third one for fans, and so on. And based on that, they monitor the behavior of the customer, the behavior of the demands, and even they can give you a recommendation. Please switch off this or that, will give you some incentive, will give you some credit. This credit, because they have to balance their supply and demand. So if there is more demand, they will give credit, or they increase, for example, the electricity price, and vice versa. So they can control it. You can have 24-hour system, running system. One of the main things which needs also understanding is about blockchain market. What is blockchain market? It is communicating whatever. It could be, you know, now is Bitcoin is one of the technology which is used. You can communicate energy, for example, with others, which means you can produce energy, and within the system, people will trust you as an energy or service provider. So, and based on that, you will have credit. So briefly, I'll explain the blockchain idea within this example. For example, Alice wants to pay Ben for some electricity, and the first block is created online. Okay, it will be communicated through the system, and Ben will be considered a trusted person. Then the transaction will be approved to deliver the electricity to Ben. So briefly, you can have, let me say, different farms and so on is producing electricity, and you as an end user or customer, you have the privilege to select which one you trust and which one is cheaper to you. So, so this is how does it look like. They have conducted experimental work, and they, within a relatively short period, 431 transaction has been conducted. Of course, we are talking about not money transaction, we are talking about energy transactions, energy exchange. So as you can notice here, Industrial Revolution technology, it has been proven for other applications, and it has been tested with feasible solution for microgrids, for remote areas, with different Industrial Revolution options. And this is of course, now with more policy to be developed, with more feasible solutions, you will see in the near futures more applications. And if we consider here in Saudi Arabia, as you're aware, the smart meters almost installed in the residential sectors. So more data will be available to the decision makers, to the energy suppliers, and where you have more data, you can analyze that data better, and you can create new extra business from this data, and so on. So this summarizes my presentation. If you allow me just shortly, I can present the KFUBM capability, which is relevant to what I discussed, but I'll go through it quickly. So within KFUBM, we're talking about energy. We have teams which are working in renewable energy. We have another team working in energy efficiency, and recently we have more focus group to work in the Industry Revolution 4.0 in the energy sectors, with different, of course, conventional application, as you can see here, and with some future or futuric applications. And of course, within KFUBM, we are working in different areas from water desalination, from air conditioning, from PV system, CSB, solar thermal, grid integration, and energy audits. This is only within energy sectors. And of course, we have a lot of labs where we test practical systems, either solar-based, PV-based desalinations, or battery testing, solar thermal, outdoor testing, and indoor testing. And we have proven and some labs, you are welcome if you would like to visit them. For solar thermal cooling lab, we were able to approach 8.5 and 9 degrees Celsius. In the system here, in this experimental work, we reached to 9.3 degrees Celsius. Of course, we have recently just installed PV air conditioning systems using DCA system from the market. We have, it is about to start in a couple of weeks. So it is around 7.7 kilowatt system. And we have installed also smart meters because we want to monitor all the details. There will be also some data acquisition systems. So we'll have in a few months complete picture how good and how much you can save with DC air conditioning system. We have installed also smart meter in different locations for comparison purpose. In addition, one of our colleagues, he did also extensive experimental work for air conditioning and control system for a given house or a given building here, as you can see here, which consists of blinds, lighting. This is the data acquisition room. We have humidifier, electrical heaters, light indoor, and so on. And we have sensor everywhere. And this sensor gives you also some prediction and recommendation. First, you are collecting a lot of data, and you can predict and give a recommendation where how you should operate the room to have this energy consumption. So these data, as you can see here, we have temperature data collected, we have humidity, temperature. So each number here represents one sensor values, either temperature or humidity or radiation. Is the blind or the curtain here is opened or not? The window, is it opened or not? The light, is it on or off? The fan, and so on. So such work we went next, and we tried to expand that one. For that reason, we are expanding this project to more advanced one, which is we are going to implement it for a selected mosque in KFUBM. As well, this is also for information. We have also smart renewable energy grid labs. We can conduct also some studies about dust assessments, either in the PV systems, and we built some experience and lab facility with Fraunhofer here, and we did also some experimental work earlier with MIT, and still we can run this project alone. We have some testing facility in KFUBM Beach for KFUBM different centers. We have also some educational programs. We have also our partner here. We conducted a lot of successful projects with different partners from all the main stakeholders within Saudi Arabia. And I would like by this to thank you for your attentions, and I'll be glad to take your questions. Thank you.
Thank you very much, Dr. Fahad. That was really, really interesting. Great presentation, and also the work done by the center is very impressive. So I think we have time now to take questions. So if anybody has any question, please type it in the chat box, and Dr. Fahad will be happy to answer. So there was a question earlier regarding membership in the AE. So I included the chapter's email address in the chat box. Anybody who's interested can email us at that address. So Sonala, as there was another poll that I was hoping to launch, but I'm unable to do that. Are you able to do that from your end? Just one last question to...
Yeah, let me see if I can launch it.
Okay.
Yes, I launched it.
Okay, very good. So this question is if anybody is already a member of the AE, the international organization. So please let us know. We'd like to know that. Okay, so Dr. Fahad, we have a couple of questions now arriving. So the first question is if the university have implemented or participated in nearby microgrid.
Assalamu alaikum. Maybe I'm not fully aware of everything, but as what I am aware of it, we did already several simulation based on we have RTDS systems here in KFUBIM, as I showed in the picture here, and we have conducted here for KFUBIM different studies for grid stabilities and so on, considering some power within I can say microgrid and so on.
Okay. Another comment from Abdulaziz is saying he hopes that KFUPM gets benefit of Arizona State University. Apparently application of solar energy. So I think he's suggesting to look into case studies from Arizona State University. A question from Abdurrahman Ashur is, in using advanced models and algorithms for demand versus supply balance, how accurate have you seen the prediction found in the solution output when compared to actual consumption versus predicted one? So I guess the question is like, how reliable can we feel about the outputs from simulation and modeling tools compared to the actual consumption of a system in real life?
Sure, inshallah. First, the first comment about Arizona State. Thank you for raising this comment. Arizona State also, they visited us, the vice president and with his team visited also KFUBIM around 4 years. So we have some communications with them. We check also their websites, what they are doing. And the main point about Arizona State University, they are doing excellent work and they have relatively harsh weather. So it will be always good example for KFUBIM or any entity within Gulf region to consider it as a good example. For the demand and supplies, of course, there is a prediction about it. And there is an error within that one. The main point here is with more advanced, let me say, prediction tools, with more data you have, with more data you collect, you will have much better predictions, and the errors between supply and demands will be much lower. I mean, in terms of prediction. On the other side, of course, if there is a certain of potential error, you should have also some safety margin, so you will be in the safe side. However, this error and safety margin with time will get smaller and smaller because of the advancement of all the ecosystem in general.
Okay, thank you, Doctor. More questions are coming. Abdulaziz Sanusi is excited to hear about the great research you presented to us, Dr. Fahd, today. He's wondering how can he get in touch with researchers from the center. Is there like a way to contact the center to ask about a specific type of research, or to approach one of the researchers?
At the last slide, I have the email, but if you can kindly send me email, I'll be okay. Happy to direct him to the right person.
Right. So Sanallah, maybe you can help us if you type the email address maybe in the chat box, or I think Dr. Fahd is showing the email here, so okay.
Sure, I can just type it.
Okay, great. So there is also another question coming in from Ali Zahrani. Did you try to come up with models to evaluate the consumption pattern over different periods, day, week, month, year?
For myself, no, but my colleagues, they did it. And we conducted several projects either in the architecture engineering department, in mechanical and electrical engineering department. They have already conducted several projects about demand and supplies and prediction. So such information is available, and if Dr. Ali is willing to have more information, I'll be glad to take his questions.
Okay. Very good. Ziad Asker is asking about the residential tariff in Saudi Arabia, wondering why is it that the residential consumer does not receive instantaneous tracking of his electricity consumption, and wondering if we in Saudi Arabia typically use smart meters on homes.
Of course, smart meters are almost installed in every place now in Saudi Arabia. When this information is activated, I think it will go through phases. So they will collect information, but eventually the smart meters, many types of them, have the capability even to provide you an instantaneous instantaneous consumption of your electricity, and if you reach to a specific number or limit, it can for the cost consumption, it can give you a notification.
Mr. Muhammad, let me clarify my question.
Okay, go ahead, please.
Thank you, Dr. Fahd Usman. I'm one of the students in KPBM. I work in energy efficiency and renewable energy. It's been addressed widely in KPBM, mashallah. Let's say more than 90% of Saudi houses have smart meters, yeah? And why is that?
ما نسمعك ترى صوتك يقطع. لا.
Monthly bills. So this thing will help the consumer to adjust his.
معلش ترى بعض الكلام يقطع عندك ما سمعنا. I cannot hear you well. يعني some of the words you are mentioning is interrupted with the connection. Is it from my side, or if it is?
No, I think it's from his connection, but it looks like he's realizing the benefit to the consumer if he gets that notification, like everybody is aware of his consumption pattern, so they know the consumption minute by minute. So like maybe the owner would make something out of that information if he actually receives it.
The smart meters, I'm not sure about the specification of what is existing now, but I think it has a lot of capability. And one of them could include also instantaneous consumptions for you. And if there is more smart meters, and for your information, it can give you also a recommendation. And if the tariff is constant now, but maybe if there is huge demand during summer, it can give you a recommendation to reduce the consumption with some credit. If you have PV systems over your roof and you can estimate the power production versus the one coming from the grid, it can give you also some recommendation to optimize the consumption and reduce your electricity bill. The smart meters have a lot of capabilities. I think, or I guess it will go slowly with more capability toward you, and it will be driven by the market, security, and policy.
Very good. So the benefit is not mainly for the utility company. If this information is available to the consumer, then he can make something out of it and maybe change his behavior. So very, very good point. Basil Suberi is concerned about what might happen if all these new electronic smart devices, what comes with the IoT environment, if everybody starts to use them, should we be concerned about the grid, the power quality? Would it affect the power generation, the power distribution network?
Yeah, if we talk, for example, about rooftop PV systems, in distribution level, regulators, they put maximum limit. First, there is a maximum limit if you want to have grid-connected PV system. It is not opened for you completely and not opened for your neighborhoods. Within some distributions level, there is a maximum energy where it can be installed, or PV system. So to be sure that it will not create disruption to the grid. Second, each PV system, it has some inverter, and this inverter, which is also pathway toward the grid connection, it should work within specific range of frequency and voltage, so it will not disrupt the grid. So if there is, for any reason, it works out of this range, it will be off the grid. It will not connect to the grid.
Okay, great. We have a few more minutes. We don't want to take a long time, but I think Faiz Al-Jabri, he works with the power regulator, so he would like to say a few words to address that point. Faiz, you can unmute yourself, I believe, if you have any thoughts to share with the group.
Yeah, Assalamu alaikum and good evening. I'm very glad to be with you all, and thank you, Dr. Fahad, for this informative presentation. Actually, I wanted to add to what Dr. Fahad has just answered about the making the information about the consumption to the residential consumers. Actually, one of the main functions that the regulator has demanded to be available in the smart meters is to have that information available to the consumer himself. And we are in constant discussion with the utility, and an app is being developed, and it will be launched very soon. That once launched will be available to all consumers to enable them to monitor their consumption on a constant basis. That will help, as Dr. Fahad said, once the customer knows his consumption, he would have, let's say, the incentive to rationalize his consumption and use it as he really needs. So that will be inshallah ta'ala available very soon.
Okay, great. This is fantastic news, Engineer Faiz. And we invite you here that, inshallah, once this app is ready, we would like to have a presentation in one of the coming AE chapter meetings about that. So we have, I think, just one, maybe two more questions from Yasser. With all these advancements surrounding energy sectors, when do you think we'll move totally to the industrial revolution, tech as source of energy? And there was also another question about, where do you see more potential in renewables or in IR4? More potential for research, like where should we try to focus more the research, solar or IR4 technologies?
So to answer the first question, when we are going to have more, let me say, technology to be implemented 4.0, more application. First of all, we have to see what is leading the market. Leading in the industrial revolution is not the energy sector. It is the communication sectors, the social media sector. So, and robotics. This, I think, what is leading now toward more adoption. As we have more adoption toward that one, everything will follow after that. Now, it has been experimented in many places. I showed only a few examples, and I'm sure there are more better demonstration to implement it now for the microgrid because of the flexibility to control, to monitor, and we don't have to worry about regulations and policy. So there are some obstacles, as I showed before. One of the main obstacles is to have more comprehensive and demonstration project about this one. Now, where we can reach more mature industrial, let me say, industrial revolution, energy-based systems depends on the adoption. For me, I don't have specific dates at this moment, but I'm sure in a few years you will see very excellent examples. Maybe within NEOM's project, they are going to adopt a lot of advanced technology in where it is practical to have what is called macro or similar to microgrid, like Red Sea project, Amala project by BIF. Such project can be implemented, or any equivalent projects. So it is coming to the picture. It should be market driven. So more investment will be toward that one to accelerate the implementation.
Okay, great. Amin Bernawi, Dr. Fahad is saying, I will start my PhD research after 1 month.
Allah
Inshallah. What's the best area in renewable energy that's going to be helpful for the future? Can I work in solar systems with AI? If yes, like which research subject you suggest? So, Doctor, please go ahead and answer. Meanwhile, I'm going to share the invitation for next week or in 2 weeks event. And this is especially for Amin Bernawi because this has to do with his interest in artificial intelligence. Go ahead, Dr. Fahad, please.
Maybe if you can communicate, send me email, I can meet with you and discuss. I should have a better understanding what is your background, which university you are working on, and so on. But anyway, when you select a topic, look for the future and something relatively more applicable, not too much theoretical. So just think about what is to be about to implemented in the future and can be implemented here within Saudi Arabia. What can fit for harsh weather. Otherwise, you are welcome to send me email and we can meet and discuss it in lengthy meeting.
Very good. A quick piece of advice to Amin. Maybe one of the things he can consider battery systems, energy storage have a lot of future in terms of research. So that's an area maybe you can consider. So one last question here, and we hopefully we will end by that. It's from Muhammad Ahmed Sadiq. He works in IESO in Ontario. Very nice presentation, Dr. Fahad. Thank you very much. Just quick question about policies and regulations. Do you think we will have some regulations for energy efficiency soon? Also, is there any provisions for transactive energy platforms in KSA?
Is there any what?
Regulations. I mean, definitely we have a lot of new regulations coming. I think the question is more, is there any provisions for transactive energy platforms? So exchange of energy probably.
In Saudi Arabia, we don't have yet open electricity market.
Yes.
This is also one of the main challenges to implement it in large scale. And it may, for that reason, it may start with maker grid and independent grid. This is one of the challenge. However, of course, we are working, the government and the energy sectors are working heavily to start with having open electricity market. For the policy and the regulations, still I'm not aware of anything published relatively. However, it will be based on market driven. And here, the overall policy and regulation is available, but if it is something special with the data management and these things, it can be considered from two different point of view, either from communication point of view or electricity point of view. So from my side, I'm not aware of a detailed one for now.
Okay, very good. I think it's almost 8 now. So we had a great session today. We're really grateful, Dr. Fahad, for you.
Just if I can add, usually such meeting is registered online. Sorry, it is recorded. And usually, not always, usually also it will be available through KFUBIM website. We have what is called Knowledge Institute at KFUBIM, KICS, or Knowledge Institute KFUBIM Exchange. So you can check it there in a few days, and they will usually also they put it in YouTube.
Okay, great. So Nala Sayed, we really also thank you very much. And we felt we are in safe hands today, and you're running the platform. Things are going smooth, so we really appreciate it. And we appreciate really everybody who helped from the center. As I mentioned earlier, the collaboration between the chapter and the center has been going on for several years. And we worked closely with our friends there. I see Jamilu Garbua with us today and the rest of our friends there. So this has been a great collaboration. And today's session was really great. We thank everybody for their attendance, and I'm showing here our next event scheduled in 2 weeks. This is also a very interesting one about a technology for autonomous control of HVAC systems. Very, very interesting, applying artificial intelligence technology. We will have people from Canada presenting a webinar on the 31st. So if anybody is interested, please let us know. You can email the chapter's email. So that's it. I think we can end here, and unless anybody have one last words, Dr. Fahad, Abu Yasser, I think we're about to end the session now.
Yeah, from my side, I would like to thank you, everybody who attended for our today meeting and who helped us to organize this meeting. Special thank to Engineer Mohammed Al-Wadaifi, Engineer Ali Al-Qahtani, and also to Mr. Sana and Dr. Galal, and Dr. also Mr. Engineer Jamilu and Engineer Shakil. Thank you, everybody.
Thank you so much.
Thank you, Doctor. Thank you.
Thank you very much. Thanks.